Good evening, everybody. Can you hear me? So people who are joining online, can you hear me?
Yes.
Okay, thank you. So today is March 2nd, right? And then in this week we're at the middle of the semester. So sorry. This week we are discussing function stack. We will be discussing function stack and recursion. Actually, in our last lecture, we started function stack and recursion. So we have one more lecture before we go to our spring break, right? So this lecture and day after tomorrow. So let us try to complete this module 5 before we go to spring break. And by the way, our next lecture will be also online before the spring break. So the room we take the class, there will be another professor who will be using for his test. So he sent me an email that he needs to use the room. So in our next lecture, we will do also online. Okay. Okay. So in our last lecture, we discussed uh, function stack. So actually, we discussed how a function is called. And sorry, we discussed when a function is called and what happened and how the functions if the current function execution is paused and it goes to the execution track goes to the calling function, and then after executing the calling function it comes back to the caller function and it resumes the caller function. Okay, so in the last lecture we discussed this. We went through it, and I will upload the uh, I'm trying to download the lecture video, and then I will upload this last lecture video and today's lecture video tonight. Okay. Okay, so this one we went through in our last lecture. Actually, this is the part of so function stack. This one is module 5. So part 0, and we also discussed module 5 part 1 recursion in our last lecture, and then I want to go that one also quickly tonight. Okay, so recursion, what is recursion? Can anyone please tell me the definition of recursion? Anyone from online, can you please tell me the definition of recursion?
Isn't it like when a function calls itself?
Yes. So this is recursion is a process, right? So when a function calls itself, then it is called a recursion. It is called a recursive function, and the process is called recursion. So we know that in order to find factorial of any number, we multiply the number starting from the number up to 1. The reverse order we can do it, but I'm multiplying 1 times 2 times 2, 3 times 4 up to the number. Okay, but in recursive way, it is program becomes faster because the recursive way in a recursive way program uses stack, that is called a special memory location, that is faster to execute. Okay, so this is why the recursion process is faster. So like in order to find factorial of any number, you see the large number, so you can say factorial of 75 equal to 75 times factorial of 74. And actually the rule, general rule, is that factorial of n equal to n times factorial of n minus 1. So in the recursion process, there are three requirements. Okay, these are the three requirements, must follow these. First one, so it must have a recursive call, and the recursion must terminate, must have a terminating condition, or it's called base condition, and must make progress toward terminating. Okay, so if it does not progress towards terminating, so then recursion will not happen, and then program will not terminate, and then it will not be effective. So the terminal point actually is is defined by some terminal condition. For instance, those are the condition we call base point. For instance, when finding factorial of a number, okay, so we do factorial of n equal to n times factorial 1, right? So that what will be the terminal point or base condition for factorial recursive function? Can anyone please tell me?
Can you repeat that?
What will be the base condition for factorial for this recursive function? If I want to implement a recursive function to find the factorial of a number, what will be the base case? What do you think? So at which point we need to terminate this
Would it be
factorial?
at 0 equals 1?
At factorial 0 equal to 1. That means actually the last number, when we multiply bunch of numbers, right? We cannot have any number 0, right? So if we have a number 0, then our total multiplication result will be 0. So instead, we should stop at best when, at most when our last terminal point, base point is 1, right? So when we can get 1 for factorial? For a factorial function, what is the number for which we can get 1 for factorial? 0 and 1, right? Or 1, right? Factorial 1 equal to 1, and for factorial 0 equal to 0. So for the factorial function, the base condition will be factorial of 0 or factorial of 1. Okay. So in order to design a recursive method, we first determine the base case. That is the stopping point for the recursion. Okay. And second, okay, we need to fulfill the third condition. We need to make progress toward terminating. So we need to set up our program so that it towards through termination. So here, in order to find factorial of a number, right? So we actually think that all factorial methods, almost all factorial methods, take at least one argument. Okay, all factorial methods take at least one argument. So for instance, here when n equal to 1, that means we return 1. That is the base case. Okay, so this one is the base case. Actually 1 is the base value, and this is the base case. We could say when n equals 0, then return 1. That would be also, that would work. But even we say if n equal to 2, so what will be the return value for factorial? That means what is the value of factorial 2? If we say n equal to, are you with me?
Is it 2?
Yes, if we say n equal to 2, then we should return 2, right? Okay, so then If we say n equal to 3, so what will be our return value? Yeah, go ahead, please. So what is the factorial of 3? Factorial of 3 equal to 3 times 2 times 1, right? So that is 6. So if we say n equal to 3, then we should return 6. But so we can have any base condition and any base value, but we should not select base condition n equal to 3 or n equal to 4 or n equal to 5. For instance, if we say n equal to 5, then we need to return 120. So that means in this case, what is the limitation of that? This program will be, you cannot find factorial of any number that is less than 5. Right? Do you understand the limitation? Why I am saying that you cannot find with this program, with this method, factorial method, if you design by this way, you cannot find factorial of 4, factorial of 3, or factorial of 2, or factorial of 1. Do you understand the reason?
Yes.
Yeah, what is that? Because the base case, it determines the lowest value. Okay, so for instance, by designing a factorial method like this, we can find the factorial of 5 at least. At least, yes. So better we should have factorial of 1, then return 1. Okay. So then, which will be the rest of the code? So rest of the code is easy. So otherwise, if not it is n equal to not equal to 1, then what we do? We have this value. We need to return this value. Okay. So this is the basic code. You could write this code in many, like in multiple ways, in several ways. There are several ways to find factorial. For instance, you can say you can define another variable. For instance, int fact, a variable equal to initially 0 or initially whatever is 1 or 0. Then you can say, then if n equal to 1, then you can say fact equal to 1, and then you can say else, I'm sorry, why it is not working, else you can say fact it's not working, equal to n times, and you can say then return. Why it is not working? You can say return fact. So it will not go. It will also work. Okay. So you are declaring a factorial, any value, any variable, and if you say n equal to 1, then fact equal to 1. This is the base value, right? Else fact equal to n times factorial of n minus 1 and return the fact value. Has anyone any question? Are you okay? Has anyone any question? Okay, so that is an implementation. So that means we can have a little bit different implementation, but all implementation will be pretty similar or identical. Whatever you say, actually this code is the simplest form, or you can say. Okay. So now, in order to call a factorial method. Okay, when you design a factorial method, if we design like it is as a static method, then we don't need to create a new object of the class. We can call it directly, and we can say int f equal to factorial of 4. Actually, I don't need it to print it here. Actually, then it will print factorial 4. Well, over here. Has anyone any question? So if I go through replete, RPL, okay, sorry, factorial. So recursive factorial methods in C# or Java. I do have both Java and C#. So you see that I have multiple, there are a number of ways, okay, to make factorial recursive method. Okay, so there are 3 methods over here. I'm sharing this code with you, okay? So please practice this, okay? Okay, so it has multiple implementation, okay? So a little bit different. So you see that using while loop you can do. Okay, there is a different way. So instead of fact total, I can say fact. Okay. So the remaining slides, it just traces how the factorial is called. Okay, so if n equal to 4, then the remaining slides, it shows initially print n over here, and then if n equal to 1 is not equal to 1, so it will come over here. So it will be factorial of result will be 4 times factorial of 3, and then factorial 3 will check, will go to its call itself, and it is not 3 not equal to 1, so it will skip the if condition, then it will go to the else condition, and then so at this point, what happens that in the factorial method, you need to understand that one at this point, instead of printing this line, so it will pending its work, and it will call itself again. Okay, until it resets to the base condition, it will be calling itself again and again. So the print method will not be executed here until it finishes. Okay. So please trace these slides, and you see that how slide to slide different, and then what happens when at some point it will collapse the stack. That means stack memory will be, when stack memory will be used, then release, actually stack memory will be released at some point, and then it will go back order. It will return value, and you will see that at this point it will be printing. So I like you to copy this code and print it in your program and paste it in your program and try it. Okay. So in Eclipse, or if you had Eclipse or NetBeans or JGraphs, you can trace your program. Okay, so you can run it step by step, and you can see this effect, this output. Okay, there is a common term, it's called stack overflow. That means at some point, okay, stack will be full, and then so then the program will not give you expected result. Okay. Okay, so there is another example, that program, please practice it. How to find power, it's called power, recursive power function. Okay, power function. For instance, recursive power function, then how can I find x to the power y? If x is a number, hopefully an integer number, and y will be a positive integer number. So, but in this case, both x and y are positive. So that's in this case, power function, it calls itself with y minus 1. Instead of calling y, instead of x minus y, it is calling y minus y. Can anyone please tell me what does this mean? Can anyone please tell me what does this mean?
It's raising x to the y minus 1th power.
Now what will happen here in this case?
You would be raising x to 0.
X is not 0 actually, or if y equal to 1, right? So then what will happen? So for instance, we want to find 4 to the power, like this way, right? Like 4 to the power maybe 5. Then what will happen? Okay, so this function, if says this value is equal to 1, then it will return x, it will return 4. Okay, if it is not, then what it will do? It will do x time, so it will do 4 times. Okay, then it calls itself, then power will be, x will be same, and then power will be 5 minus 1, 4. Okay, you understand this one? So in the next iteration, what you'll do, equal to 4 times 4 times 4 power, this time will be 3. And the next iteration, what you'll do, equal to 4 times 4 times 4 times 4 times 4 cap 2. Okay, x will be same, but power will be less, right? Oh, okay. So then maybe I can call this way, maybe power 4 to the power 4 here, power power 4, 3, and then power 4, 2. Okay, and the next time it will be next iteration. It will be 4 times 4 times 4 times 4 times power 4 and 1. Okay. So what will happen at this point? So here this y equal to 1, right? So then at this point, if y equal to 1, then what will it return? X. What is my x value? Is 4. So then it will be like this, equal to 4 times 4 times 4 times this 4 times, for this one it will return 4. You understand why it is 4? Because our base case says if y equal to 1, then it is returning x, right? So this is x, right? So then it will be like this. The ultimate result will be 4 times 4 times 4 times 4. Do you understand this? Has anyone any question? Has anyone any question?
No, no question.
Okay, thank you.
You're
So
welcome.
then, okay, so this is the program. This is the solution. You can get it. This is my program. You can get it. Okay, and this is the last program. Okay, so let us do. Okay, I like someone me to write this code. You can copy and paste this code in a program, and then you can explain to us. Okay, let us do an activity. Who wants to volunteer with me? Someone is calling. Hey James, are you in? Someone like James. Oh, someone is asking me how can I just join the link. See the link in announcement. Okay, who wants to volunteer for me? You can share your screen. Who wants to volunteer for this one?
I'll volunteer.
Okay, click on the, you see that, you see my screen. Click on the here, there is up arrow button. Up arrow button, you see? Up arrow. I'm okay, so at this point I am closing my sharing, okay? So I think you will have an experience. Okay, you see that this, oh, you cannot see. So on the right side, okay, yeah. Now go to Replit, please.
Okay.
Yeah, I see your screen.
Guest version of Replit.
I'm expanding the screen, okay, so that it is.
Okay, so I'll just copy and paste that code from the PowerPoint.
No problem. You can give a good name, okay? So actually, when you see that, when you click on yes, click over here and give a good name. Actually, I give a good name so that I can remember it, okay? I do not like default name. Yeah, recursive. Okay, that's good.
So it was the first PowerPoint.
Yeah, the last one. Yeah. So okay. So yeah, you please take volunteer for me 5 to 7 minutes. I'm taking a break. Okay, I will get in 5 minutes back. I'm getting a coffee.
Okay.
Yeah, you please speak loudly. Okay.
Okay.
Thank you.
So we're gonna call the program print number. So I'm just gonna make a new file. Okay, let's see if it works. It doesn't work. Anyone knows what's wrong, they can tell me. Oh, it's because it's the method. It's not, I need to make a class. Okay, I can just put this in main then. I thought I was looking at a class earlier.
I think you just put it outside of the main.
Yeah, right now you have it below main, and you're not calling anything in main except hello world.
Oh. The call print. Oh, I have to call it public static. There it is.
Good job.
Okay. Wait, is the professor back?
I think the exercise is for, I mean, the number, it works, but I think it's for 30, not 5, just FYI.
Oh. Okay, I'm just gonna try to figure out like how this code leads to that output. Okay, so it gets 30 here, and then it prints 30, then it does like the recursion with 30 minus 1. So it prints 29, and then it says when it gets below 0, I don't know what happens then, why it goes back up again. 。 I think if we take this line away, it won't go back up.
Yes, if you take off this third line, it won't go back up. Try and see.
Yeah, I think when
Yeah.
there's another, when it call itself again, so it went into another method. So all the way down to 0, then it jumped back.
Okay.
Yeah,
one
because
thing-
once it does like print number 0, then it won't go through that if statement, and so then it'll go back to where it paused in like the one above it. So then print number is 1, and it'll be at that since it was doing the print numbers n minus 1. So then it'll continue and then print out what n was in print numbers 1, and then it'll keep jumping back and back and back in 2, 3, 4, 5, 6.
Oh, okay.
Yeah, so it was like paused at that print numbers n minus 1 line every time we went into the print numbers method. If that
Okay,
makes sense.
so- yeah, you will understand this.
Yeah, we're trying to make sense of it right now.
The last one. So okay, so yeah, please comment out line number 12 for now. Line number 12. Comment it out. Yes. Okay, and then and that line number 10, instead of print ln, just put print. Line number 10. In the line number 10, yeah, just put. Okay, and one more thing. Let us make it simple. Instead of calling 30, just put call with 10, not 30, 10. Yeah, 10. So yeah, now print, run it. Let us see. Okay, so now what do we see over here? What is printing here? So you can delete hello world. Okay, so line number 3, you don't need this, right? Okay, now run it, please. Okay, so now it is simple, right? Everybody understand this, right? So everybody understand why it is happening, how it is working.
Yeah, I understand this part of it counting down.
Okay, now let us do something. Now comment out line number 9. Comment out line number 9, please. Okay, and then uncomment line number 12. No, it will not give any result. Uncomment line number yes 11, and then instead of print ln, put print line number 11. And the line number 11. Yeah. Now line number 9 and line number 11 are same, right? You understand? Line number 9 and line number 11, those are identical, right? But the output, you see that output, do you see any difference in the output?
Yeah, it's counting up.
Yeah, so why it is happening? Do you understand? Can anyone please explain me what is happening here?
Because it's waiting until after it calls itself to print what n is.
Yes. So when it
Because the only line that executes is line 11. Line 10
Yeah.
does not execute no more.
yeah, but our question is that if there are two lines, right? Line number 10 and 11. So if you move the line number 10 down to line number 11, that the output will be in different order. So now the output we see that in ascending order, right? Output 1, 2, 3, 4, ascending order, right? From smallest to highest, right?
Yes.
Okay, but just if we move the line number 10 after line number 11, okay, that means the same thing, like making line number 11 commented and then enabling line number 9. So then yeah, make line number 9 enable. Yeah, and line number, okay, first of all let us see. First of all, line number 9 and line number 11 are exactly same, right?
Yes.
Okay, that is just printing n and then a space. So if our print statement goes before the recursive call, then what will happen? And if the print statement goes after the recursive call, what will happen? There are two different things, right? We are trying to understand this. So now disable the line number, comment out the line number 11, please. Okay, before you run, okay, don't click a run button. Now tell us please, what will be the result?
He will count down.
Okay, what will be printed?
Because the method will be called on line 10 and it will execute line. No, I messed up.
Yeah, so who can explain us, please?
Won't it be 10, 9, 8, 7? Well, 10 space 9 space 8 space 7 space 6 space 5 space 4 space 3 space 2 space 1 space.
Yeah, so why that will happen? That's good. Why that will happen?
Because every time that the print numbers function is called, or method is called, after it prints the end value, it recursively calls the print numbers method again for n minus 1. So it decreases in value over time.
Yes, you are correct, exactly correct. So here at this position, when we are calling the print number method, it is printing fast, right? So whatever the value is, it will be printing. The first value it is called by 10, so it will be printing 10. After printing 10, so yeah, please run. Now click on the run button. You will be confused. The result is up order. Yeah. So now it will the print method, print number methods, when it is called, so that whoever calls it, no matter. So the print line number 9 will be executed and it will be print n. So if you are calling this n equal to 10, right? And after printing 10 value, it will be calling itself with 10 minus 1, 9 value, right? And when it calls 9, print line with 9, then it will print 9. Okay, and this way, how far it will go? When it will stop?
It will stop when n will be equal to 1.
Yes. So instead of if n greater than 0, okay, what are the other way, at least one way that we could rewrite the line number 7, the base condition? Is there any way that we could rewrite it in a different way in line number 7? Yeah.
And greater or equal to 1.
Yes, write that on, please. So at this point, what will happen?
It'll
It will
go
stop
down
at
to
2.
2.
Okay, it will down to 2. Okay, but we want it. If we want it to down to 1, then what do we need to do?
Greater or equal to 1. Yes.
Yep, you understand, right?
Yes.
Okay, that's good. So everybody understand this?
Yes.
Okay, so this is the way that you should, whenever you get some program code, you should try yourself. Okay, make some changes, and even before you run, click on the run button. Okay, take a piece of paper and then find the result and write it down on a piece of paper. And then when you run it, match your result output with the console output. And if it is they're same, then it's good. And then if it is not same, then you need to rethink about, right? Okay, good catch. So, has anyone any issue with this one? Or you wanna say something?
Why does it count back up after or for line number 11?
Line number 11 is disabled right now. Okay, so are you taking that if we disable line number 9 and make the line number 11 enable, then what will happen? Are you asking that?
Yes.
Okay, let us do that, and then before we run it, let us explain. Let us try to understand. Yeah, make the line number 9 commented. Yes. So then it was your question, right? Okay. So what happened? Can anyone please explain other than me?
I know that it it will start at 1 because the if condition says if n is greater than or equal to 1, so it'll start at 1, but I'm not sure why it increments by 1 after that.
Okay, that's good. Let us see if anyone has any understanding. I will go through this. Can anyone please?
It shouldn't be 9, 8, 7, 6, 5, 4, 3, 2, 1 rather than without the 10. Because you're subtracting before you're printing.
Go a little bit more explanation, please. In detail. First time, what will happen? So when it calls print number 10, then what will happen?
I mean, this output will print out from 1 to 10, and that is from what I've understood or what I created in my mind is that we're calling a method, sending the 10 first, but from that method we call again the method and again till we get to a point where when we call the method, we get the input that we're sending is 0. So at that point, that's like a wall, and the method goes back and starts running what was supposed to go after calling the method. So pretty much we just kept calling the method till we get to 0, and then we pull back to when the method had 1 and it runs then whatever was next, which is printing 1, and then goes back to the one before it was prints 2, and then so on and so on. And that's why we get the 1 through 10. That's what I think.
Okay, you are good. So you have it's very detailed. Okay, but anyone has any shortcut way? Different one? Anyone has a shortcut way you can explain? That's good. Your understanding is good. But anyone can explain it shortly, briefly, in a different way. No matter, don't feel shy. Okay, even if you do not understand, I will help you. But I'm trying to get it from yourself.
I think what he said was right. You take the 10 and then it's going to keep going down, but like it's going to keep like going down and down, but it doesn't get to the print statement until it's gotten to 1, until like it's hit that wall, and then it starts printing everything back again.
Okay, yeah, what will happen actually? Yeah, you're correct, but give me my understanding. Let me share. Okay, so what will happen when you call for n equal to 10 value, right? So then it will be calling, okay, n equal to 10, okay, but it will be calling print number with 9, n minus 1, 9, right? Okay, and the 10 value will be kept in stack. Okay, and then what will happen? Then print 9 will call print number 9 will call print number 8, and the previous 9 value will be kept in stack. Okay, and then when it has print number 8, it will keep 8 on the stack, and then it will call 7, print number with 7, and all the way. So that means it will put 1, 10, 9, 8, 7, 6, 5, 4, 3, 2. It will keep all of these in stack. It will not be printed. Okay, but what we'll do at this point, when it gets in greater or equal to 1, so then it will print it 1, and then after it printing 1, then it will get the stack value back. Okay, so what is the last value of this on the stack was 2, right? The 2 will come back, so it will print first 1, then it will print 2, and then it will call the next value, next top value on the stack, that was 3, so 3 will be printed, and so on. It will be, then next time it will be printed 4, then 5, 6, 7, 8, and all the way 10. 10 was put on the stack very first time, right? So on the stack, it's like a plate. We will discuss stack later, okay, in this course. So like a stack of plate. So whenever we wash plates and put one above another, the first plate we wash out, we put on the way back. The last plate we wash and we put all the way top. And usually when we use a plate, that we get the top plate, right? So the last value are stored on the stack was 10. That will be all the way down, and the print will be printing that 10 all the way end. Okay, so now click on the run button, please. Yeah, now we got 1, 2, 3. Okay, this way. Now, has anyone any question?
Yes. As far as the stack memory goes that you were just talking about, every value that's printed, every value that's put into the
stack.
Yeah, but every value that's a parameter in the method is put into the stack memory.
I think it's every method call, right?
Every method calls, so then the value will be put on the stack. Actually, we will discuss stack after our for a few weeks. So then when we discuss stack, then it will be clear for you. Actually, at this point, you may not actual idea, but I can explain you later. Give me a second.
Okay. Should I stop sharing my screen?
Give me 1 second, please. I want to take a screenshot. Hold on a second, please, so that I don't need to type in. I can get this going. Yeah, you can now. You can stop sharing. Okay, but before I go through, so thank you for your collaboration. Okay, and but one thing that, so is it okay that I publish the entire video with your voice and with your demo, with your part?
Yes.
It's fine.
Okay, because of the FARPA law that it says is restrict us. Without your permission, I cannot publish your voice. So you're fine, right?
Yes, I'm fine.
Everybody is fine?
Yes.
Okay, that's good. Thank you.
Yes.
Okay, thank you. So now let me share my screen. Okay, let me share my screen. Okay, and then So IPE. Okay. So like stack is like this, okay? In stack, for stack, one side is closed. This is called stack. Stack is a data structure, and stack is in terms of computer memory. It is a memory, special memory space. In the computer side, we in the computer or hardware we have RAM, ROM, right? You understand? So one part of RAM is called stack. Okay, so in stack is LIFO, LIFO, LIFO. That means last in, first out type data structure. What will happen? So then when you call this with 10, right? So then every factorial method, I told earlier maybe that every factorial method uses stack. So it holds the stack before it calls itself. Okay, so it holds the previous value 10 on the stack. Then it gets print number with 9, right? It calls itself with 9, right? 9. 10 minus 1 equal to 9. Then when it calls itself, then it again put 9 on the stack. Then it calls itself with argument 8. Then again it puts 8 in the stack and then call it by print number 7. Then print number again say 7 again calls itself with print number 6, but before it calls, then it gives 7 in stack and calls 6, print number 6. And this way 6 will be stacked. Okay, and by this way all the way top, whenever it goes, at least whenever it goes, you see that when n greater or equal to 1. So what is the least greater value of 1? The next greater value of 1?
2.
So next greater value of n, that is the next value of n that is greater than 1, 2, right?
Yes.
Okay, so you see 2. So when it gets 2, then it will not call itself, then it will print. Then instead of calling this, okay, then actually is equal, so it is equal. So actually it will call solve for 1 also. So then stack, it will print, keep 1 also in the stack. So then when it gets 1, is it equal? 1, then it will be printing stack value. So then what value it will be printing first? 1. So whenever you say print yourself, then 1 will be printed here, and there is a space in between. Okay, then 1 will be printing. Okay, and then it will get the next stack value 2. So 2 will be printed within the space, and then dot like this way it will be printing 6, 7, 8, 9, and all the way the last stack value it will be printed 10. And with a space here, there is a space in black. This is space. We cannot see the space. See here. So this is called stack, but we will discuss stack operation at the last quarter of this course, or in your data structure course. We will discuss stack operation. So is everybody understand?
Yes.
Okay.
I think so. Yeah.
Okay, that's good. So this was a test question in a previous year. Okay, but if we make some changes in this test question, okay, you should understand that, for instance, if we want to print instead of the number itself, we can print the square of the numbers, right? For instance, if we want to print like this, if we want to print 1, 4, 9, 25,
No, 16 first.
Oh, yeah, 16, yeah. Thank you. 16. So let me do dot here. $100. So if we want to print like this way, okay, will you be able to do it? What changes we need to do?
You can do math.pow.
No, I don't like to do that. I want to do with recursive method. Think about, we are close. So here, think about a second. What changes we need to do? Print here. Little bit change in this program. Just a little bit change. One change, single change.
For line 9 and line 11, instead of n, put n times n.
Yes, on the line number 11. Line number 9 is disabled, okay? In this case, so line number 9 has no function here. So line number 11, on line 11, put print n times n plus space. Did you understand?
Yes. If we write 9 square, it will print the same thing.
This 9 square here.
Yeah, instead of saying n times n, we say n square.
This is n times n. That means other way you can type in n. Maybe they can use square function, but maybe I'm not sure that in some languages it uses n times 2. You said this one? Are you talking about this?
No, I'm talking about n square. N power 2. N power 2.
This is n power 2.
Okay.
N times n equals to n power 2. This is power. In some languages, it uses double star to make power.
Okay.
But I'm not sure that every language does this. But this is the naive way, and then this is a good, right?
Okay, yes.
Okay, now let us question 1. Let us make it a little bit tricky question. So how about how to print all how to print squares of all word numbers. Okay, from 1 to n. In what is this order will be? This is ascending order, right?
Yes.
It's called ascending order. But if you put print line number 9 and make line number 11 disable, then this will be descending order in ascending order. So that means what I want to do, I want to print 1, then 9. I want to print then 25, and then last one I want to print 81. How can you do that? using recursively, okay? Print, so the condition is recursively. We need to do it recursively, not manually, not using for loop, okay? So in this program, we need to do a little bit trick. Okay, what do we do? We need to do. What we are printing? The square of odd numbers, right? 1 squared, 3 squared, 5 squared, 7 squared, right? 49.
Call print numbers 2n plus 1.
No, think about it a little bit more. Maybe you're close. We need to give an extra condition here. Between line number 10 and 11, we need to add one more line. Do you think what we need to do?
If n mod 2 equals 1.
Yes. If n mod 2 equal 1, then print, right? Then print. Print n times n plus some space. Okay, now if you understand this, then you should understand how to print the odd number, square of even numbers, right? The next question I can say Q3 will be to print 4, then 16, then 36, and then 64, and then last 100. How can I do that?
N times 2.
No. Here we need to do if n
It's the same
modulo
thing, except
2
you just 2 is
equal to 0.
0. Yeah.
Then print n times n plus some space. So everybody understand this?
Yes.
So this is the way you should practice programming, okay? You should practice problem solving, how to solve a problem. You see that a little bit changes, a little bit change in your program code, it will give you some different result. Okay, so we got some different experience today, right? Okay, in the upcoming classes, if you are interested to volunteer, that will be appreciated, okay? Okay, has anyone any question?
I was wondering if there is any quiz due this Sunday, teacher.
Maybe not. When I was making the course schedule, I did not try to keep anything due before the spring break, because
Okay.
no, let me double check, because I'm no longer the coordinator. Okay, someone else is coordinator. I moved to computer science department. So let me see what is that. Oh yeah. So I originally designed the course this schedule up to version 2 or 3, and then I handed out the responsibility to someone else. Okay, yeah, he followed me. So there is nothing due in this weekend, but in our next week we have one more slide, okay, for the recursive, this one. So I want to discuss this one in our next lecture. Okay, so
Okay.
only a few slides, but I want to discuss this in our next lecture. Then we will see that we will get something. Okay, now we will learn some application of recursive method. For instance, display string in recursive order or something. Okay, so the last lecture will be, I think last lecture will be short. An hour for the last lecture will be good. Okay, if you have some time, please download this slide and then read. Try to understand as much as you can before you come to our next lecture. If that is better, if you do not understand, if you try to understand ahead of time, and even if you do not understand, I can explain you, then you will have better understanding. Okay, and then one more thing is, for my class, please do not feel shy. Okay, please do not hesitate to stop me at any point. And if you are interested in presenting something, okay, and for instance, it is true that sometimes you think that, oh, I could explain the better way, explain it in better way than the professor. If you think that I'm not explaining something in better way clearly, you can stop me, okay, and then you can tell that, you can share your idea. I would appreciate that. Okay, for this program we discussed, right? On the left side is C# code and the right side is Java code. So okay, has anyone any questions so far for today?
No.
Okay, so our next lecture will be also online. So before we go vacation for spring break, because the classroom wants, another professor wants to take his test for a long time. So in my previous lecture will not be here there. So to make it online in this lecture. Okay. Is there anything else that I could discuss?
No.
Real quick, I was just curious. So for collections, is calling something last in, first out the same as saying like first in, last out? Or yeah.
This one?
Yeah.
So it's called LIFO. You call it fast in, and then stack is called LIFO, last in, first out. And then you see, you want to say fast in, last out, FINO. You want to say this one? Do you want to say this term? You said, are you talking that you want to say this one as fast in, last out?
Yeah.
Like FILO. You wanna say
Yes.
You can say, but people, this is a well-known terminology, LIFO.
Okay.
I never heard this word philo. Okay.
Gotcha.
Okay. I think fast in, last out. Actually, when we go to stack operation, stack one side is closed. Okay, so then the stack cannot come to the last position until it goes to all other top positions. So then it comes from the top. So in stack, one side is closed and one side is open. So all input operation happens one way. The output operation also goes same way. Yeah, but you got a new thought. Okay, I never thought that way. Okay, so it could be you can done, but maybe okay. People just says LIFO. Okay, your trade being graded, and then hopefully we will finish grading by this Friday. By the weekend, you will wanna publish our grade. But in this class, I actually lecture the last moment. I give you some idea for different different pattern of output using recursively. Okay, please practice this. Okay, and then if you get stuck, then please feel free to let me know. Okay, thank you everybody, and you have a good night.